Distinguished guests to other representatives from Princess Julapon High School, Nakhon Si Thammarat. Today, we're proud to present you nano composite bags from natural rubber, reinforced with nanocellulose from polymerase peel, or you can call it polymer bag. Did you know the number of Thailand's plastic bags waste in 1 year is equal to 37 Titanic ships? From this, a lot of plastic bags waste it can cause many problems such as air pollution or water pollution. Furthermore, in our community, we have Taptim Siam Pomelo. It is the main economic food, but it can cause a lot of waste too. More than 64 million kilograms per year is happen because of its fuels. In addition, in south of Thailand, we have rubber. Rubber it is the main economic plant, but now the price of rubber has increased more than triple for 10 years. So it's caused a lot of damage for agriculture. So we want to invent something that can solve these three problems in our country. And now we find it. We're proud to present you polymer nano composite bag. Next, scientific theory of nanocomposites. We add sulfur to natural rubber and add zinc to nanocellulose when intramolecular hydrogen bonds which could produce a large number of free OH groups at the surface of the cellulose molecules. The resultant OH group at the cellulose surface were activated and could form complex with things during bone milling. The incorporation of fuelers makes interruption in the element process of change. When fueler loading is increased, more weak interfacial regions between fueler surface and rubber matrix are formed. The resultant zinc cellulose complex diminishes the crystalline nature of the composite. About methodology, in order to generate nanocomposite bags, it's easy to create nanocomposite bag because we have only three methodologies. First is extraction nanocellulose from polymerase peel. Second is cross-link nanocellulose and natural rubber with cross-link agent. And the last one is testing of nanocomposite material. It is the result of our nanocomposite bag. This is the result of experiment. The same image of the nanocellulose at different concentrated sulfuric acids to extract from polymerase peel. It was found that 47% sulfuric effect to nanocellulose size smaller than 37% sulfuric acids that affect to cross-link process. Next, is it the result at the different concentration and clearly explain the homogeneous dispersions of nanocellulose in natural rubber matrix and the wide presence in 10% and 15% nanocomposite is probably due to the agglomerate nanocellulose presence at the higher weight percentage. After the 10% nanocellulose, it is difficult to process the composite. Due to the higher viscosity and the composites become failure due to incomplete wetting of the fiber by natural rubber latex. It can identify the dispersed nanocellulose. Nanocellulose appear like nodular network and their concentration is a direct function of the cellulose compositions in the composites. The surface of the film is smooth and the nanocellulose are highly individualized and homogeneously distributed within the matrix, especially at lower concentration. It is the result about tensile strength of composite polymer. It is often that the tensile strength of nanocellulose and natural rubber nanocomposites significantly was improved with an increase of nanocellulose content. But when compared with composite polymer-based tensile stress is 1% nanocellulose and 3%, 5%, 10%, 15%, and 20% nanocellulose was increased respectively. In addition, 1% nanocellulose has tensile property more than natural rubber 3 times. These results show about efficiencies of shape memory property in composite polymer. You can see that 1% and 3% nanocellulose are the highest shape memory property because of natural rubber content in nanocomposite polymer. It has alkene group in natural rubber that increase shape memory property. This graph indicated about the degradation efficiencies of composite polymer. The degradation test found that 20% nanocellulose is the best concentration for degrade at 49 days, and 1% nanocellulose is the lowest concentrations for degrades at 2 months because of 1% nanocellulose has a strong cross-link bond. Next, it is about conclusion and discussions. Our innovations have high tensile strength similarly to plastic material, but it more benefits because it has high shape memory property. That's more than 99% in 30 minutes, and it can degrade in 2 months. When polymer bag degrade, it can add macronutrients and micronutrients such as zinc and sulfur that can increase growth rate of seed. About the marketplace in the future, we think that our main customer and target is convenience store and department store. So we think that we can extend the target more than 16,000 branches, and it can grow in case 6% in 1 year. After that, we will improve our innovation to be necessary backed in order to extend customer and extend the market in the future. About the social impact, our innovation is eco-friendly because it's made from natural. It is such as natural rubber and polymer. Furthermore, our innovations can degrade in 2 months, so it is not cause the damage or effect to environment. And our innovations is very distinct. In size of 25 square centimeters, it can bear the weight more than 5 kilograms. If you want some innovation that from polymer and rubber, please choose polymer bag. Thank you for your kind attention.